In this video, we're going to talk about solving linear inequalities. And in one of our previous videos, we described what each of these symbols mean. So we'll have to remember that as we go through the process. So in our first example, we have negative 2/3 is less than 2b plus 1/3. So we treat this inequality symbol as if it were an equal sign. We still have the left side of our inequality and the right side of our inequality. Our goal is to isolate b. So we're going to solve the same way we would if it was an equation. So we're going to subtract 1/3 from both sides to get rid of all terms that don't have variables. Negative 2/3 minus 1/3 is negative 3/3, but negative 3/3 is really just negative 1. So we have negative 1 is less than 2b, and then 1/3 minus 1/3 is 0, so those are gone. To finish solving for b and isolating, to undo 2 times b, we're going to divide both sides by 2. So we have negative 1/2 is less than 2b divided by 2 is just b. So this would be the solution set to our inequality. If we wanted to graph this, negative 1/2 is what we're comparing to, so I'm going to go ahead and put that right here. If we want to give some other tick marks, this would be 0 and negative 1. So first of all, from our last video, we showed you how to graph. So we're going to put an open circle on negative 1/2 because our solution doesn't actually include negative 1/2. It doesn't have an equals to underneath our inequality symbol. So we want to figure out which way we're going to shade. So we can pick a test point. I could test if b were 0, if this would give us a true statement. So negative 1/2 is less than 0. Well, negative 1/2 is smaller than 0. So because this was true, we're going to shade towards 0. Every number to the right of negative 1/2 on a number line is a solution to this inequality. We can also rewrite this as b is greater than negative 1/2. If you want to flip sides, you have to also change the direction of your inequality to make it a true statement. So either of these would be solutions. Let's take a look at another example. In this example, there's a lot going on. We still want to think about it as the left side of our inequality and the right side of our inequality. So when you have a whole bunch happening, sometimes it's hard to know where to start. What I like to do is look at this side over here where there's some more stuff and see if I can simplify this or get rid of some things. So right now, n is trapped inside of this term, which is a fraction. So before I can do anything with that, I want to get rid of the other terms that are on the same side of my inequality. So I'm going to subtract 8 from both sides so that I only left with that fraction term. So we have 3 plus 2n over 4. 8 minus 8 was 0. Is less than 4 minus 8 is negative 4 plus n. So now that I have just the fraction over here, we can get rid of the fraction by multiplying both sides by the denominator. This is where we have to be really careful though. On this side, when I multiply by 4, well, 4 divided by 4 is 1, so those cancel out. I'm left with 3 plus 2n is less than. On this side, though, I have to multiply everybody by 4. So we have to actually distribute, because there's more than one term, the 4 to both of them. So 4 times negative 4 is negative 16. 4 times n is 4n. So this looks different than this because this was just one term. This is 2 individual terms. So when I'm multiplying this side by 4, it cancels out. But when I'm multiplying this side by 4, I have to distribute to both terms. So now we have variables on both sides, so we're going to get all of our variables on one side. I'm going to go ahead and subtract 4n from both sides. 3 minus 2n is less than negative 16, and 4n minus 4n 0, so those cancel. I'm going to keep solving, subtract 3 from both sides. 3 minus 3 is 0. We have negative 2n is less than negative 19. And this is where things get a little bit different from solving equations. I'm still going to divide both sides by -2. But what happens, I'm going to write my answer up here, is that -2n divided by -2 is just n. -19 divided by -2 is just 19 halves. But because we divided by this negative right here, we have to flip our inequality symbol. So now we have n is greater than 19 halves. And the reason for that is when you divide by that negative, it's like crossing over 0 on the number line. So now things that used to be less than are actually greater than. So our final answer should be n is greater than 19 halves. If we graph this, you can put 19 over 2, if we turn that into a decimal, would be 9.5. So we can put 10 to the right, 9 to the left. We have an open circle because it's not equals to, and it says n is greater than 19 halves. So again, we can test. If I test n equals 10, well, we would get 10 is greater than 9.5, and that's true, so we're going to shade in the direction of 10. I want to look at this one more way from this step right here. So I'm going to take this and solve it one more time. So this was our third step or something when we were solving the inequality before, and this was the answer we got. The last time I took all of my variable terms and put them on the left side. This time I'm going to take all my variable terms and put them on the right side. So we're going to subtract 2n from both sides. We have 3, 2n minus 2n is 0, is less than -16, plus 4n minus 2n is 2n. We're going to add 16 to both sides. We get 19 is less than 2n. Divide by 2, just like we did before, so we get 19 halves is less than n. So when I did it this way, I got this answer. Well, if you look, this is the answer I got the first time when I had to switch the inequality symbol because I divided by a negative. Those actually say the same thing. N is greater than 19 over 2. Well, n is greater than 19 over 2. So that's why, another visual for why we have to flip the inequality symbol when we divide by that negative, because if I had just moved the variables to the other side, I should get the same answer regardless of what I do. So that's it.